And our final one in our derivatives of logarithmic functions. We're going to talk about being serious. Look at that. Look at that. Serious. We got to talk about an exclamation point. Or actually, what the heck is n factorial, huh? What's that? And here's its quick definition. It's just 1 times 2 times 3 times 4 times dot dot dot. We'll add to numbers smaller than it times itself. Let me give you an example. 1 factorial is 1. 2 factorial is 1 times 2. 3 factorial is 1 times 2 times 3. Notice how I don't care what the numbers equal. Don't stress about what the numbers equal. 1 times 2 times 3 times 4. We're catching the pattern. So there's n. It says add it all the way up. We're assuming, of course, n's bigger than 5 or 6, yeah? Yeah, when we write it like that. But that's the game. And then we have something by definition. 0 factorial is also equal to 1. So you don't have to worry about that. So you can divide by 0 factorial. You can't divide by 0, but you can divide by 0 factorial. If you are a student that's even thinking about grad school as an option, you're going to want to know this. A lot of times we skip over stuff from statistics because you're badass STEM students and you don't see this. But it ends up on what's called your GREs. So if you are looking to go to grad school, you would need to know a little bit about it. So getting some knowledge now, that's not the worst thing in the world. And we're just going to look at patterns here. This is getting you prepped. This is getting you ready to go for the next class. Maybe we'll play a little bit of this game. But just looking at some patterns, sequences, series, good stuff. All right. Here's the basic game. But let me write something else in. n minus 1 factorial. Now this would be 1 times 2 times 3 times 4 times dot dot dot. We'll go up. Well, dang, we need to go one smaller than it. Maybe n minus 3, then n minus 2, and then we get up to n minus 1. That would be n minus 1 factorial and how we'd write it. All right. I want to find the nth derivative of f of x is equal to the natural log of 1 plus x. We're going to use patterns to figure out no matter what you say. So if you say, what's the 9th derivative? We're like, well, we could just plug in a 9 and have a formula for it. Nth means just any number. Just come up with a frickin' find the pattern so we can just plug the number in. Don't build it from scratch. Find the frickin' pattern. So that's what we're going to do. So I'm going to take multiple derivatives and see if we can't catch a pattern. I'm not going to put the numbers together, so don't try and solve the numbers. We're looking for a pattern. So let's take our first derivative, our first. And this is going to be f prime of x is equal to 1 over 1 plus x. But I'm going to begin writing this just a little bit differently as 1 plus x to the negative first. Okay, there's our first derivative. Now let's go to our second derivative, f double prime of x. And this one's going to be, let's work off of this. This negative 1 is going to fall to the front. And it's going to change to negative 1. And let's write in the negative 1 times 1 plus x raised to the power if we subtract 1 from negative 1, and that becomes negative 2. All right, now let's do the third. You got to catch the pattern. So you start looking, trying to find it. So our third derivative. So now that negative 1 is still going to hang out, but that negative 2 needs to fall. So we put in negative 2 times our 1 plus x to the subtract 1 to the negative third power. Neat. It looks like that's positive there. And this one up above is negative. And then the first one was positive. All right. Let's just keep going. Let's just take a fourth and see what the heck's going on. So we're going to write the fourth derivative here. So we got our negative 1 times negative 2, and then our negative 3 is going to fall to the front. Now we got 1 plus x to the negative fourth. Well, shoot, I think we can catch a pattern by this time. It looks like this is just getting bigger and bigger and bigger. So on our fourth derivative, we have the fourth power. On our third derivative, we have our negative third power. Sorry, I should have said negative. Second derivative, negative second power. First derivative, negative first power. Bro, I think we can do this. Let's get rid of all this nonsense, but I think this one's going to work out okay. Let's write it off to the side. Or no, do right underneath. So our nth derivative, or after the nth. So let's just write this 1 plus x to the, and we'll write in, instead of 4, 3, or 2, or 1, we'll write in, since those all match, we're going to write into the negative n. Cool. So whatever derivative you're taking is 1 plus x to the negative blah. But now we need to figure out the pattern that's going on in here. First, let's start with the signs. Let's just start with the signs. So we have, this is positive, then negative, then positive, then negative. So it looks like every odd term is positive and every even term is negative. So this is a game we play. You just take a -1 and you raise it to a power. And we think about, if n was odd, what would this turn out to be? If n was like the number 1, wouldn't this be equal to -1? Oh shoot, we want it to be positive. Crap. So what we're going to do is we're like, well, wait a second. Do you know how you want to change an odd number into an even number? Add 1 or take 1 away. So maybe we do this. So now when you plug in an odd number, put in -1 to the 1 plus 1, right? So now our n is 1. That's +1. Good news. We've changed what we call the index. So when this occurs, we want it when the odd term is positive, the even term is negative, the odd term is positive, the even term is negative. We want to use this little -1. Actually, I'm going to do it all in black. Sorry about that. We want to do it as -1 to the n plus 1. It's a game. It's just a little game. And notice I'm just dealing with the number, or the signs, not the numbers. And now we can look in here and see, what do we got? So on our, let's start here. On our fourth term, we had 1, 2, 3. On our third term, we had 1, 2. On our second, we just had 1. And on our first, well, let's see if we can't catch that pattern. Doesn't it seem like whatever term it is, we're doing 1 less, so 1 times 2 times 3 on the fourth term. We had 1 times 2 on the third term, and I imagine you'd have 1 times 2 times 3 times 4 for the fifth, and 1 times 2 times 3 times 4 times 5 on the sixth. So these are our ith terms, or nth terms, so maybe we just say it's n minus 1 factorial. It's 1 less than whatever term we're at. 1 less, so then we're going to say n minus 1 factorial. And if you wanted to truly clean this up, it's -1 to the n plus 1 times n minus 1 factorial all over 1 plus x raised to the nth power. This is a lot. It's a lot. I think this might be more geared towards, yeah, it might give you a pattern problem, but I don't know if I'd even make it this rough on you. So patterns, n factorials, multiple derivatives, nth things, talking about the nth something. That's a rough leap. So, all right, that'll do it for this section. We'll just have a couple quick things. I think maybe you'll have 2 videos at most for your next section, and we'll go straight into your exam 2. So good luck to you. Yeah, I'll have a couple more, but that should do the bulk of everything that's going to be on your exam. All right, see ya.